Hello guys, so in this video we will study about deadlock prevention, avoidance and termination. So first thing is I think deadlock prevention. So for preventing deadlock, what can we do? I will discuss in this video. Then avoidance and then termination. So first thing is deadlock prevention. So guys, deadlock prevention is nothing but as I already discussed, like you just have to violate any one of these four conditions. So you can violate so you can't violate mutual exclusion. So if mutual exclusion is there in your system, then your system will not have any deadlock. And then hold and wait. Then I think non-preemption. These are the things that I have discussed in previous video. So non-preemption. Okay. And another thing is circular wait. So you just have to violate any of these situation to avoid deadlock. Okay, so deadlock prevention is nothing new as we already studied in the last video. So you just need to keep focusing on what is deadlock prevention. So I'm just rubbing this thing. Another thing that is most important is deadlock avoidance. So for deadlock avoidance, uh, what a deadlock avoidance says, it says that you if you cannot prevent a deadlock, then you can avoid the deadlock. So why we came to deadlock avoidance? So the thing is deadlock avoidance. So why we came to this thing? Because on deadlock prevention we have starvation and latency delay. Okay, because in hold and wait, one process has to wait for another process to release the resources, so it will create a starvation as well as a latency delay. So for this deadlock avoidance came. So what deadlock avoidance is that uh, as much as you can avoid the deadlock, just avoid the deadlock. So for this you can use the banker's algo, and you can use the uh, resource allocation graph. Okay, so these are two things that you can use for this. But the question is, so for Bankel's algorithm we will make a separate video because it is like uh, there are some numericals which comes under Banker's algorithm, so we will make a separate video for it. But uh, for resource allocation graph, so as we have already seen the resource allocation graph, but see this thing, this is a new concept. So this is a resource R which is having two instances. This is R1 having two instances of R1. So this is also R1 and this is also R1, and it is allocated to P1, but its one instance is allocated to P1 and another instance is allocated to P2, and P2 wants the same instance of R1. So R1, so this will create a deadlock, and this is actually a resource allocation graph. Now the question is, if resource has single instance, then is cycle like this is waiting cycle like P1 is waiting for R1, okay, and R1 is allocated to P2 and P2 is uh, and R2 is allocated to P1 and it is waiting for, and P2 is waiting for R2. So this is a cycle. So if only single instance of each R1 R2 is available, then is cycle a necessary condition for deadlock? So this is a question. So the answer is yes. So if there is only one instance of every resource, then cycle is a necessary condition for deadlock. But if multiple instance of R1 is there, so let's say this instance is allocated to any process P1, but this instance is free. So in this case, we can allocate this instance to P2 also. In this case, it may be deadlock, but not always deadlock. So when it can cause deadlock if P2 wants all two instances of R1. So if P2 wants two instances of R1, then yes, deadlock. But if P2 wants one instance of R1, then no deadlock. So this is basically a resource allocation graph. Now the another thing is, what is termination? So termination means, like word is saying, termination. So termination means to terminate the process. But when we are going to terminate the process, which process should we use to terminate first? So for that, you can use multiple algorithms. Like you can terminate the low priority process, you can terminate the uh, large process. It depends on your algorithm. So for termination, you can use low priority process, and you can use large process first. But make sure that you cannot terminate those process whose output is dependent on other process, like batch process. So for batch process, you should not terminate this. So, but for low priority and large process, yes, you can terminate if they are not dependent on other process. And one more thing, that these termination will happen one by one. So one by one, you can termination So the termination step is one by one. One process will terminate, then another process. Okay, so these are the important theory points in deadlock. And now moving towards the one question that frequently asked in competition exam. So let's move towards the question. Okay, so the question is so first, before moving towards the question, just write a formula. If there are n instances of resources, p processes, and resources allocated by r, so r resource. So if r is greater than or equal to p into n minus 1, so if it is equal to p into n minus 1 plus 1, then it will not have any deadlock. So if this condition holds, then no deadlock. So if there are three process, four instance of resource, okay, four instance of resource, then if r, for what condition of r that deadlock will not occur, so then it will be 3 into 4 minus 1, that means 4 minus 1 plus 1, that will be equal to 10. So if there are 10 resources, then there will be no deadlock. So this is all about deadlock, and for bankers algorithm we will make another video. uh, Thank you.